To monitor temperature and humidity of the surrounding using DHT11 sensor and display on LCD. So let us see here in this project, what are the components used? Before that, let us know what is the aim of this project. See, in the surrounding, we need to measure the temperature and also the humidity. So most of the time we required for the surrounding these parameters to know. Then we can further action can be taken. So here we are going to use the sensor as DHT11 sensor. It is a digital humidity temperature sensor. By using this sensor, we are going to measure the temperature and humidity of the surrounding. And same thing we are going to display and also display on the serial monitor. Now let us look at here. We are going to interface your DHT11 sensor with Arduino. So this is a DHT11 sensor, and this is as we are going to just represent temperature and humidity. This is symbol, and it is Arduino. Arduino is the main controller. So using this, we are going to control. It means we are going to read the data from DHT11 sensor, and then after processing, we are going to send to the LCD, and also we are going to send to the serial monitor. So this is just components here I mentioned. One is DHT sensor. We are going to use the input, and this Arduino board is a controller. Our controlling function is going to perform, and here the output is an LCD. So these are pin connections. How we are going to connect this LCD to the Arduino, and also DHT sensor. DHT sensor is having 3 terminal, VDD, ground, and data. Okay, this VDD you are going to connect to the VCC of the Arduino, and ground you have to connect to the ground, and data pin is connected to the pin number 7 of the Arduino pin. Any digital IO pin you can connect. So here we chose as pin number 7. Now similarly we can connect the LCD. LCD here 4 data lines we are going to connect D4, D5, D6, D7, and these 4 lines we are going to connect to the 4, 5, 6, 7, 4, 3, 5, 4, 3, 2. We are going to use the pin numbers 5, 4, 3, 2. So that is D4 pin is connected to the pin number 5 of the Arduino. D5 is connected to the pin number 4 of the Arduino. D6 is connected to the pin number 3 of the Arduino, and D7 is connected to the pin number 2 of the Arduino. So this is actually we connected this LCD with the Arduino board, and this is a DHT sensor. Just one snapshot, this one. Then before to execute the program, here we need to include the library. We are using library in this program. That is the DHT sensor library. So here the procedure how to include. So this program required DHT11 library. So it is taken from the Adafruit. To install libraries, go to the Sketch menu. In this Arduino ID tool, you have to open, then it is available. Sketch, the option Sketch. In that, include library will be there. In include library, if you click, you can able to see manage library. You click on manage library. Then search for DHT11 sensor here. Then you have to click on install. Then once if you install, it will show the installed. So this is how we are going to install the DHT11 sensor. So now the components required to perform this function: the Arduino Uno board, DHT11 temperature humidity sensor, LCD display, and this 10K potentiometer to vary the brightness of the LCD, and breadboard, than jumping wires. See here, Arduino is actually it consists of hardware and software. So Arduino consists of the hardware board of microcontroller based, and also it is having ID tool, integrated development environment, that also we are going to call as an Arduino. Arduino is a microcontroller based open source electronic prototyping board which can be programmed by using Arduino ID tool. So Arduino, it consists of a Atmega 328P 8-bit microcontroller. This is Atmega 328 8-bit microcontroller, and it is having 0 to 13, total 14 digital I/O pins. These digital I/O pins can be used to connect any of the I/O devices. It is having one TX and RX for serial communication, and it is having analog pins A0 to A5. There are 6 analog pins. These analog pins are used to connect the sensor, which is going to give the analog output from the sensor, that we need to convert it to digital before doing further calculation. So in such cases, we are going to use the analog input pins. Then we have VIN, power in this all, ground. Then there's another one, ground, 5 volt. This 5 volt can be used for connecting other external device if anything required. Then 3.3 volt, this also the power you can use, and this is a reset pin, then IO reference. So this side we have the ground, another one ground is there, and SCL, SDL line, these for I2C communication protocol. This is a power jack, and this is for USB, and this is a reset pin. So now if you look at this, the same board, just for specifications has been mentioned here, digital pins. This is for microcontroller, analog input pins, power port, voltage regulator. Then this is a crystal oscillator, USB interfacing. There is one IC will be there here, USB connector, and reset pin. And these are RX, TX, LEDs. LED will blink whenever it is sending the data through RX and TX. So LCD, liquid crystal display, it is used to display the character. Here, it consists of 16 columns and 2 rows. So each row can be used to display the maximum 16 characters. So this LCD is having the data lines D0 to D7. Out of these 8 data lines, here we are going to use 4 data lines. Then there is a VCC, then ground, then for contrast, varying this brightness, then RS, register select, read write enable, and read write and enable. These 3 control signals we are going to use for LCD to configure and also to display the data on the LCD. Now here, DHT, digital humidity temperature sensor. Let us see a brief about this DHT 11 sensor. So in this DHT sensor, there is a thermistor with a humidity sensor component. It's having both temperature sensor as well as humidity sensor. The resistance change between the 2 electrodes is proportional to the relative humidity. Here the 2 electrodes will be there. The resistance between these 2 electrons is going to change according to the humidity. High relative humidity reduces the resistance between the electrodes, while low relative humidity increases the resistance between the electrodes. If resistance is more, means humidity is less. So DHT11 also includes the thermistor, that is NTPC, thermistor, negative temperature coefficient, to measure temperature. A thermistor is a thermal resistor whose resistance changes rapidly with temperature. The word NTPC means negative temperature coefficient, which means that resistance decreases with increasing temperature. Here the opposite. When temperature increase, the resistance will decrease. So hardware overview of the DHT sensor. DHT sensor is having 3 terminals. One is VCC, ground, and data. So DHT11 is a digital humidity sensor, temperature sensor. It measures humidity from 20% to 80% with an accuracy of 5%. Similarly, the temperature range from 0 degree to 50 degree with plus or minus 2 degree centigrade accuracy. Now let us look at the program. So here we discuss about the sensor and also LCD. Now about Arduino also we discussed. Now let us see about the program which we are going to execute on the Arduino board. So here the program encode this header file we are going to encode, that is dht.h. Then we have to include another header file liquid crystal.h. So this DHT1 consists of DHT11 sensor also. We just include DHT.h. Okay, it takes DHT11 also. Then liquid crystal LCD. Here we are calling the function. So to map the pins of the LCD. First one is register select, second one is enable. Then this from third onwards it is data pins D4, D5, D6, D7. So actually it is a 4 pin. Okay, 4 pin. Till D7. It starts with D0 till D7. DHT, here we have created an object as DHT. So further in the program we are going to use as DHT, capital DHT. So here define DHT11 pin 7. Means here the pin number 7 we are giving one constant name, that is DHT11 pin. So whenever we say DHT11 pin means it is a pin number 7 of the Arduino. So this program consists of 2 functions. One is white setup, another one is while loop. In white setup, the statement that is going to execute only once in the program, that we are going to input in the white setup, and the statement which is repeatedly to be executed, that we are going to input in the loop. So here to display the character on serial monitor, we are going to use serial.begin. The baud rate, that is 9600, you have to use. Then LCD.begin 16,2 means 16 cross 2 LCD to begin, to start LCD begin, to display the character on LCD. Then now white loop will start. Here it is going to execute repeatedly within white loop, whatever you are going to write. So now int check DHT dot read 11 DHT pin means pin number 2 is used to, pin number 7 is used to read the temperature and humidity from the sensor and is connected to the Arduino. So the functions already is written. It will read and store into the CHK variable. Then set the LCD cursor position 0th column and first row. So for that LCD set cursor 0, 0. Then on LCD.print, you have to display this temp on LCD first. Then LCD.print DHT.temperature. So DHT is the function dot temperature. Temperature will be displayed on the LCD. Then LCD.print, this character will be displayed on LCD. LCD.print C will be displayed. Later C will be displayed. That is temperature measured in centigrade. Then set the cursor LCD.set cursor. This is 0th column and second row. Now LCD.print, this will display humidity on the LCD. Then LCD.print DHT.humidity. This is going to display the humidity on monitor. Then LCD.print, the percentage will be displayed. Then 1000, this is 1000 milliseconds. That is equal to 1 second. You are waiting here 1 second. Then we are sending the same, whatever we displayed on LCD, also on the serial monitor. Serial.print temperature, and then serial.println DHT temperature. From DHT sensor, we read the temperature that we are going to display on this serial monitor. Similarly, serial.print humidity, the humidity will be displayed first, and that DHT humidity will be displayed, then wait 1 second and it will repeat. So here it is going to display temperature and also humidity on serial monitor and also on LCD. Okay. So now that the one screenshot I used here about the program, this Arduino IDE tool we are going to use for editing the program and also compilation. Then also to program, I mean to download this hexa file into the target board. So first we are going to edit the program in this IDE tool, is Arduino IDE. So after editing, then you click on this compile and upload, both it will perform. So this is the display what we got, the readings from the DHT11 sensor. So thank you for listening. Further, if any assistance required, please feel free to contact. And also you can WhatsApp or you can email. You can go through our website. So further, if anything required, please you can contact. Thank you.